Hello everyone. In this video we're going to do a quick review of chapter 8, which is where we first learned about confidence intervals. So we're going to also kind of tie in chapter 10, which was when we started doing a two sample, the difference between two values. But what is a confidence interval is you use it to estimate a parameter. So actually I'm going to draw a picture, I was going to write that out, but so confidence interval, you get your point estimate, which that's your statistic, your value from your sample, and then you get your margin of error, and you go that far away on each side of your point estimate, and you create this interval. And what is that interval? It's however confident, so let's say it's 95% confidence interval, then we're 95% confident that the true value falls within this interval. So if that margin of error is 0.5, then we are 95% confident that our true value is 0.5 away, within 0.5 away from our point estimate. So we use this interval to estimate a parameter. What is a parameter? The true value or the population value. That's just a vocab word you should know. Population value. So it says use your green inference. I mean, we didn't get to that, but it's just, you can go back and review state, plan, do, conclude. So your state is, we are estimating at a blank confidence interval the true whatever in context. Your plan are those conditions. Is it random, 10% if you're doing a random sample without replacement, and then if it's a proportion, you check large counts. If it's a mean, you check central limit theorem to know if it's normal. Your do is where you calculate all this, and then your conclude is that same sentence. We are blank confident that the true value falls within, however we worded it, but I think y'all get what the gist is. So if not, I'll post to Khan Academy, and you also should have your chapter 8 notes. Decide what you're trying to estimate. So you are either estimating it's going to be a mean problem or a proportion problem, and that's all we covered. Chapter 12 talks about creating a confidence interval for a slope, the true slope of something, but again, we didn't get to that. So it's really, you're just trying to decide, is it a mean or a proportion problem? And so we do not have confidence intervals for chi-square. Remember, that was chapter 11. We did not, you only do significance test. So again, it's just means or proportions. So as we increase the confidence level, the width, so let's think about this. If you want to be more confident, if you want to go from 95% confident to 99% confident, how are you going to do that? Well, you're going to include more numbers, right? The more numbers you include, the more confident you are that you captured that true interval. Because if you did 0 to 1,000,000, then we're probably 100% confident, but that's not very useful. So you want to find that sweet spot where you have a high confidence, but your width isn't too large. So all it say is, as you increase the confidence level, the width of the interval should also increase. So make sure that makes sense. Also, something that's not in here that I want to write down is, as we increase the sample size, what do we do? What does that do to the width? Which the width is your margin of error, right? Think of, as we increase sample size, we know we decrease variability. So we decrease the width, which would be the margin of error. So ideally you want a large sample size because you can get a smaller width but still have a bigger confidence level. So remember, what is the difference between Z and T? So we use Z when you know the population standard deviation, and you always use Z for proportion problems. Alright, proportion is always Z. When do you use T? When you use the sample standard deviation, and your degrees of freedom depend on your test, right? So if it's Z, oh, and I didn't do that right. If it's a proportion problem, you automatically use Z. It's either a Z interval or a Z test. If it is a mean problem, where you're estimating mu, and you're using X bar, it could technically be either Z or T. Z is if you know your population standard deviation sigma. T is if you don't know the population standard deviation, you only know this sample standard deviation, which is Sx. So if you want to break it down, and you'll probably be fine, is you can say P is Z and U is T, and you're probably going to be right, because normally if you're estimating the population mean, then you also don't know the population standard deviation. And so if it's a T distribution or T interval, then you have a degrees of freedom. So your mean, if it's a one sample or paired data, your degrees of freedom is n minus 1. If it's two sample mean, then you use whatever the calculator gives you, because it's not going to be the same, or the minimum n minus 1, because you have two different samples, so you take the smaller n minus 1 from the samples. But that is not going to be the same as this. That's like a conservative degrees of freedom. So normally you would do this in your calculator and just write that degrees of freedom. And then we didn't get to slope, so again, this doesn't really matter. But if you were going to do a slope test from chapter 12, your degrees of freedom would be n minus 2. And so you always need to check conditions, right? Especially because your whole test is free response. And write down, I'm going to add to this, always check conditions and write down everything from calculator. You want to be safe. And label it. So what is the formula they give you on your formula chart for a confidence interval? It's your statistic, which that's your point estimate that goes in the middle, plus or minus, and then you go this amount away, so this is your margin of error, the critical value times the standard error of the statistic. So that's what we have here. So your statistic is like this point estimate, PE, and then plus or minus this amount that you go away, critical value times standard deviation, is your margin of error. So it says it right there, but I'm going to put it ME also. So we need three things to calculate a confidence interval by hand: the statistic, the critical value, and your standard deviation. So your statistic is your sample value. So if you're doing a proportion, one sample proportion interval, your statistic is p hat. Your critical value is z star, and your standard deviation of statistic is this formula. This is all on the back of your formula chart. For one proportion, here's the standard deviation formula, and then if you don't know the true p, you would use p hat. For two samples, proportion, this would be your statistic, p hat 1 minus p hat 2. That difference is the statistic, because you're creating a confidence interval for the difference in the proportion, so it could go negative. Again, you would use z star because it's a proportion problem, and you would use this formula for the standard deviation. Now, if it's a mean one sample, you come down here. This is your statistic x bar. Now you should be using t star probably, and your formula is the standard deviation divided by square root of n. If you use t, it should be this one, because technically if you use this one, you knew that true population standard deviation, and that would be z. So just something to think about. Now this one, I would go back and maybe look at the end of your chapter 8 notes, or is it chapter 9 notes? If you need to go back, let me know. And if you can't find it, let me know. But where we talked about the paired test. So this is where you have it's not two different groups, it's pairs, and then you go find the difference for every single pair, and then that difference is your one sample. So a paired t-test is a one sample. The pairs aren't your samples, the difference numbers are your samples. So again, that could go into the negatives. So the mean of those difference values is your statistic. It would be t star probably still, because it's still a mean problem, and that would still be the standard deviation. That is different than if you just have two separate samples and you're finding the difference in the means. This is the difference in the means, or a difference of the means. This is the mean of the differences. I don't know if you need to pause and think about that. Maybe I'll try to see if Khan Academy has a good video to talk about the difference between those. And so that would mean this is your statistic, and that this would be your standard deviation formula you use. And then we didn't get to this, so I'm not going to talk about that right now. So the last thing is, your problem should give you your statistic, and they give you your n, so then you can go find the standard deviation of your statistic. What you need to remember is how to find critical value. So that is, notice these are all star. You do not use a test statistic. That is for a significance test. Critical value, what is that based on? It's based on confidence level. So this is not on your formula chart. This is just something you have to know. So if it's, let's say, we'll do Z and T. If it's Z star, if you're looking for the Z star, the critical value for 95% confidence interval, then what you would do is you would set up your normal distribution, and because it's 95% confidence, you want 95% in the middle. And so this would be a negative Z value, this would be a positive Z value. And so those should be the same number, just one's negative and one's positive. And so you can calculate either of these by putting the area and the tails. So if this is 95%, we have 5% left. So, and you divide that by 2. So you get 0.025 in each tail, because what should all this, double check, what should all these add up to is 1. So if you add all that up, it does equal 1. So that, to me, the easiest way to do this, because when you do, we're trying to find a value given the area, so we use inverse normal. And when you do inverse normal and you type in the area, it's going to give you the value with that area to the left, less than. So if you want this, you would have to do 0.95 plus 0.025, or we could just do this one and do 0.025. And then your mean is 0, your standard deviation is 1, because it's Z. And you get that, you type that in, and it's going to equal negative 1.96. Actually, it's 9599 or something like that if you round it. But now, what does the star mean? It's like absolute value. You just want the positive version. So that would be your critical value. So if it's T, it's the same idea. So let's just see how these would compare if we do the same thing, but it's T star for 95% confidence interval. Well, you would still create your distribution. We'd still put the whatever percentage in the middle, so find the area and the tails. So this is negative T, this is positive T, because it's still centered at 0, but the standard deviation is not 1 anymore. Oh, you know what, is you'd have to have more information for this one, because if you go calculate this one, let's just show you. If you go to calculator menu, statistics, distributions, and you go to, so we're not going to do inverse normal because it's not Z. We're going to go to inverse T. You would have to also know the degrees of freedom. So let's say, and N equaled 20. And what would your degrees of freedom be? You would subtract 1. So your degrees of freedom would be 20 minus 1, 19. And we'd still put the area to the left. put in your degrees of freedom. So that gives you, I put inverse T with area equals 0.025, degrees of freedom equal 19, and that gave us negative 2.093, which, again, for T star, we just take the positive version, 2.0. You could leave it at 9 or still write the 3, it's up to you. So you can see that those are pretty different. So that's going to matter if you pick the wrong one. So just to make it simple, I would say proportion problem is Z, mean problem is T. But if you understand this, that would be even better. So I think that's everything. If you want, I can also show you where you go to confidence intervals. So you would go to stats. This is if you're doing it by hand. You're creating your own confidence interval and actually doing plus or minus. If you also could go to stats, go to confidence intervals, and now Z interval, we're not going to really use that because that is not the same as this. What that is if you knew your mean population standard deviation and that was Z instead of T, and that's not going to really ever happen, so you probably shouldn't be using that one. T interval you should use, that is for this one sample T interval. Maybe I'll write down what these are in the calculator. This would be T interval. I don't know where I'm writing it here. I should be writing it like here. Two samples Z interval, again you shouldn't be using. That would be if it's two samples and you're doing mean but you know the population standard deviations. So we're going to use two sample T interval mostly. One prop Z interval would be this one proportion. And two prop Z interval would be this difference in two proportions. And don't forget that this is also like a one sample. So T interval, this would also, you would also do T interval if you were doing a difference, a mean of the differences. You would still go to T interval in your calculator. Okay. So hopefully that helps. If you get stuck on what to type in the calculator, notice here for proportions, you're not typing in the proportion, you're typing in the successes over the total for that sample. So, and it's going to calculate your proportion. So if y'all need anything as you're working on these, I know it's all multiple choice. This was created before I knew that it was going to be free response, but the reasoning is still very beneficial. So it still benefit you to do these multiple choice questions.